Wonders, Unit 5, Week 4. Comprehension skills, vocabulary skills, and short story. Remember, our essential question for the week is, how can scientific knowledge change over time? Our genre, once again, is expository text. Expository text is nonfiction text. The information given has facts about the topic in an order that's easy to understand. They support specific points with reasons and evidence, and usually they have text features such as subheadings, photos, and diagrams. One of our comprehension skills is ask and answer. Let's take a short break to watch a video on ask and answer question reading. So remember, as we
Hey eSparkers! Phew, sorry I'm late. I was reading a story and just couldn't put it down. Today we're going to learn to ask and answer questions while we read. Can you guess what kinds of questions we ask? We ask who, what, when, where, why, and how questions while we are reading. Effective readers ask questions before, during, and after they read, and we can usually find answers to our questions in three main places: in the text, in our heads, or from another source. The reason we do this is because it helps us to understand a story better. Let's look at an example. We are going to read the first part of this article from Time for Kids. The title says, "Get Moving Animals." I'm already wondering where the animals have to move and why. I want you to ask questions as we are reading too. We might not get answers to all of our questions, but that's okay. Sometimes we may want to go to another source to find out more about what we read. Let's start by reading this first part called Go Canada Geese. In the fall, geese go south for the winter. They migrate to find food. They fly for miles. Have you seen geese flying in a V shape? They take turns flying at the front of the V. Great teamwork, geese. I think we found an answer to our first two questions. Do you know where the animals fly? That's right, they fly south. But why do they fly south? Awesome job! They fly to find food. Asking and answering questions is fun, isn't it? Let's keep reading. Every fall, millions of monarch butterflies fly south too. They migrate because they can't live in the cold. They spend the winter in warm places. Are you still wondering anything? I'm wondering how else the animals move south. Do they only fly? Could some animals walk or swim? Let's find out. This next part is titled Go Humpback Whales. It says, in the fall, these whales swim south. The water in the south is warm. The whales spend the winter there. They have babies. When spring comes, the whales migrate back north with their babies. Did this paragraph talk about how animals fly south? No, we learned that some animals swim south. Great job! Let's read the final paragraph. It's titled Go Mountain Goats. It says, in the summer, these goats live on the tops of mountains. In the fall, they walk and leap down to the bottom of the mountains. It's warmer there and more plants grow there for the goats to eat. I'm still wondering where the goats go to find food on the top of the mountain. I would guess that there's probably some grass on the top of the mountain that they can eat, but I might have to look at another source to find the exact answer to that question. Throughout this video, we asked lots of questions while we are reading. We were able to answer many of the questions either in our heads or in the text, but found that we might have to find the answers to a couple of our questions from another source. While you are reading, make sure that you ask and answer lots of questions too, because it'll help you understand the text better. I can already tell you're going to do great. Have fun!
Now that you watched that video, remember that we should be asking questions about the reading. Who, what, where, when, why, and how questions will help you to make sure that you're understanding as you read. Our story this week is called Changing Views of Earth. Read about how our understanding of Earth has changed along with scientific developments over time. On the ground, looking around. No matter where on Earth you go, people like to talk about the weather. This weekend's forecast may provide the main criteria for planning outdoor activities. Where does all that information about the weather come from? The ability to predict storms and droughts requires centuries of scientific innovation. we had to look up at the skies to learn more about life here on Earth. Long ago, humans based their knowledge on what they experienced with their eyes and ears. If people could heighten their senses, they might not feel so mystified by the events confronting them daily. For example, something as simple as the rising sun perplexed people for centuries. They believed that the Earth stayed in place while the sun moved around it. This was called the geocentric model. In the early 1600s, an Italian named Galileo pointed a new tool called the telescope toward the night sky. As a result of his heightened vision, he could see stars, planets, and other celestial spheres with new clarity. Each observation and calculation led him to support a radical new model of the solar system. In the heliocentric version proposed by the scientific Copernicus, the sun did not orbit the Earth orbited the sun. These diagrams show the geocentric Earth in the center. Here's the Earth in the center and the sun and the other planets going around the Earth. The heliocentric, the sun in the center, view of the solar system here is on the right. So the sun in the middle, there's the Earth and the other planets going around the sun. Next subheading, in the sky, looking down. New technology allowed scientists to evaluate theories better than ever. Measuring devices such as the thermometer and barometer offered new insights into weather patterns. However, people were still limited to ground-based learning. What if they could travel into the sky, where the weather actually happened? In the mid-1700s, some scientists sent measurement devices higher and higher. At first, they used kites. Before long, hot air balloons offered new ways to transport the tools, and sometimes scientists themselves into the sky. However, scientists were not satisfied studying the lower layers of Earth's atmosphere. The more they learned, the higher they wanted to go. They also wanted to obtain information more quickly and accurately. Kites and balloons were hard to control. As a result, they occasionally veered off course or got lost, taking their data with them. The development of aircraft in the early 1900s promised safer ways to observe Earth's surface and the atmosphere above it. Kites and balloons could reach altitudes of approximately 3 kilometers. By comparison, airplanes lifted scientists to a height of 5 kilometers and more. Radio technology allowed scientists to transmit data from the air to the ground, where other scientists analyzed the compared information. Breakthroughs came fast and furiously. Still, scientists dreamed of reaching even higher. Here you have a diagram that shows you the different layers of the atmosphere and how high humans were able to reach. Out in space, looking back home. In the late 20th century, advances in aeronautics led to more powerful rockets that lifted satellites into orbit around Earth. From these heights, scientists could study the composition and relative thinness of our layered atmosphere. Since meteorologists could analyze multiple factors at once, the accuracy of their weather predictions improved dramatically. NASA launched dozens of satellites into orbit in the following years. Some stared back at Earth, while others peered deep into endless space. They gathered astronomical data about the ages of planets and galaxies. Sensors and supercomputers measured things such as Earth's diameter with incredible accuracy. Because of this technology, scientists could develop more reliable models about Earth's systems. For example, they could form theories to show how climate might change over time. Space missions continue to venture further from home. Even so, nothing compares to seeing Earth the old way with our own eyes. Views of our planet from space inspire awe in nearly all people who have seen them, even in photographs. With all the arguments for going to the moon, said astronaut Joseph Allen, no one suggested that we should do it to look at the Earth, but that may in fact be the most important reasons. Our other main comprehension skill is cause and effect. Here's a short video on cause and effect. Now that you watched that video, it pointed out that there are some key vocabulary words that signal cause and effect relationships. Because, why, how, those kind of words are things that you should look out for as you are reading to find out the cause and effect. Our vocabulary strategy this week are Greek roots. Here's an example of a Greek root, thermometer. We know that meter means measure in Greek. And most of you know therm has to do with heat. So a thermometer measures the heat. On your test this week, I'm going to have you take a look at these Greek words, geo, meaning earth, helio, which means sun, and centra, which means center, and find out what geocentric and heliocentric mean, using the context clues and also the Greek roots. Those are our skills for the week. Now go ahead and take a look at them again if you want to on ConnectEd and try out the quiz on forms.